Hello everyone. Up today is a new product from TexElec.com. We're proud to introduce our two boards for the PC Junior that I've been working on for the last month and a half or so. These are actually boards that I've decided that I needed for myself, and it's another one of those things that I thought, you know, if I want one, maybe other people want one. I've been collecting old vintage machines for at least 20 years now, and I've got quite a number of them, but for whatever reason I'd never come across a PC Junior. And I had an opportunity to buy one fairly cheap not too long back. Even has the Junior Captain sidecar on it for 640K of RAM, a printer port, and time. But unfortunately, as I'm sure a lot of you PC Junior owners know, there's just terrible ports on the back, and I think it was just IBM's way of getting people to buy a bunch of expansion cables. When I bought my machine, it did not come with a keyboard, unfortunately, but I was able to pick one up off of eBay with a lot of corrosion in the battery compartment. I took it apart, cleaned it, and unfortunately the corrosion was actually a little bit worse than I had thought, and the board probably is going to have some traces manually repaired and a lot of other things. And while I was looking around on the internet, I found the PC Junior forum that Mike Brutman has set up, and it's pretty neat. Definitely a site to check out. I'll put a link in it in this video. If you're a PC Junior owner and you're looking for some good info, this is definitely the best site. And while I was looking around on there, I found a project that a guy named Michael Graham worked on, and he actually created a PS2 serial port adapter, or sorry, a PS2 keyboard adapter, which would work on your PC Junior. And I thought, rather than fixing my PC Junior keyboard and messing with the weird function keys and all that other stuff, it'd be nice to just have a real PS2 style keyboard plugged in there. So I contacted Michael. He's also known as JMetal88, by the way, so if you see him on the forums, that's his handle that he uses out there. But I contacted him just to see what he would think about me manufacturing his boards for him, and he said that, you know what, if you want to do it, feel free. And thankfully, he's given me permission to create those. So just to let you know, the code for the chip on here is not mine. It's actually Michael Graham's. However, he's agreed to have me distribute them, and I think I've come up with a fairly good solution that covers a lot of bases. So there's actually two different boards that we've created. One of them is a breakout board for the CGA and the serial port, and the other one is a PS2 port. It's also got a PC Junior keyboard port in the form of an RJ12 connector, which is pretty much just a standard phone connector, not to be confused with an RJ11. An RJ11 only has 4 wires in it, and the RJ12 has 6. And you definitely want to make sure if you use one of these, you can get RJ12. But the upside to that is that any of the PC Junior keyboards already have an RJ12 port on the back of them. So pretty much using your standard PC Junior keyboard and a phone cable, you can plug it into this. And the other board, it also has the joystick ports broken out on it. So let me go ahead and get into that real quick. Here's the serial port CGA port board. This is the front of it. And what it's meant to do is literally just plug straight into the back of the PC Junior, and that way you'll have the ports that God intended on your computer. You can see that there's a CGA and a serial port here. And these jumpers down here you'll probably never need to change. Really, the only reason I put them on there is that the ports on the PC Junior, after looking through the data sheet, have a negative polarity and a positive polarity for the TTL outputs, which ultimately you don't really need to use negative. But I figured somewhere in the universe there was one monitor that wanted negative polarity. I know from some of the old Commodore monitors I've had over the years that they have a negative polarity switch on the back. So theoretically you could use them there. I don't know why you would want to, but I went ahead and put jumpers on them. But they're in the 1 and 2 position by default, and probably 99.9% of the time you'll just want to leave them there. But since the pins were already on the PC Junior, I decided to go ahead and just plumb them in. And then, of course, you've just got your standard DB9 serial port. I went ahead and used the 9-pin port instead of the 25-pin port just for 2 reasons. One, to make the board a little smaller. And 2, I think that's generally what people are used to for serial ports these days. Here's the back of the board. And as you can see, there's just 2 little headers that stick out and just meant to plug straight into the back of the PC Junior, into the ports that are there. There is one downside to this, and that's unfortunately the longest headers I could find are just a little too short. They do go in and they do make good contact, but it causes the boards to lean a little bit. So you might want to put some double-sided tape on there if you plan on leaving it permanently. I didn't do that in my video, but it's something that you could consider if you really do want to make it stay more permanently, and it should hold it in pretty nicely. This board actually stays in pretty well on its own because it's got a lot of pins that it's connecting, and it tends to stick in there pretty good. But just let me go back to the first picture real quick, and there's the front, and there's the back. And I'll demo these guys in action here in a minute. So the second board is the keyboard and joystick board. And you see this one's a little bit more involved, but basically what you've got on here is on the bottom you've got a PS2 port, and this is the PIC microcontroller that Michael Graham used to write his code for the PS2 to PCjr conversion. There's a jumper on this board, and really what this is for is to select either the PCjr keyboard or the PS2 keyboard. I'd originally just had them both connected at the same time, but I got a little bit of wonky behavior before, so I decided to just make it to where you selected one or the other. I figured people weren't going to be swapping between keyboards too much. But if you do have an original PCjr keyboard and want to use it, you can just set the jumper here to positions 2 and 3. So basically I made it to where the bottom setting was the PS2 port and the top setting is this RJ12 port that sticks out of the back. And what that's going to allow you to do is to use either original PCjr keyboard or a PS2 keyboard. Again, you just need a standard phone cable, an RJ12 cable, to plug in between your PCjr keyboard and here. And it eliminates the need to buy the rare and expensive cable that will allow you to connect it up. And if you want to use just a standard PS2 keyboard, which is what my preference is, you can jumper between 1 and 2 on the bottom, and away you go. I did actually take the infrared module out of my PCjr, just as a side note, because when I first bought it, I kept getting error B about 75% of the time when I turned it on. And error B indicates that there's either too much light coming into the infrared receiver or there's some other problem with it. And I just continued to have that issue, and I finally just took it out because I wasn't using it anyway. My PCjr keyboard, as you'll see in a minute in the video, does not work very well, although it does work enough to do a test. It's got problems, and the problems that you see in the video here were also present when I used the infrared connection. And before I even built this board, I just used some wires and connected up to the port manually. I kind of built my own cable, basically, just to test it, and the problem persisted across all the platforms. So unfortunately, I don't have a very good PCjr keyboard. However, I'm pretty confident the port's working fine because the wiring on it's fairly straightforward. So really, if all I'm doing with this jumper is moving the data pin from either the PIC microcontroller, which is reading the PS2 input, or moving it to the data pin that's on the PCjr keyboard port itself. Other than that, you've got 2 joystick ports on here, and those are pretty much standard IBM PC joysticks. The PCjr just used a different connector. I was able to look in the data sheet, figure out what pins were what, and I went ahead and put 2 ports on there in case you wanted to use 2 different joysticks. Most of like the Sound Blaster cards, for example, had joystick 1 and joystick 2 plugged in to one port, and they could use that Y cable, if you've ever seen one of those, to select either joystick 1 or 2, or to actually let you plug both of them in. And I actually went ahead and wired these this way. So basically joystick 1, if you were to put a Y adapter on it, you would actually be able to use joystick 1 and 2 with the Y adapter. And on joystick 2, I just reversed it to where joystick 2 is the primary and joystick 1 is the secondary. But you can also just plug in 2 separate joysticks into the back of it and use them both at the same time. Let me go ahead and show the back of this board real quick. As you can see, there's a little bit better angled view of the connectors. Now, one note on these, I haven't quite decided a good fix for this. I've thought about maybe gluing something under the connectors themselves, but if you just lay the connector on the bottom of the inside of the PCjr and try to slide it in, it's possible that you'll actually slide the pins, the top row into the bottom row of pins into the PCjr. Fortunately, there's no damage. I've actually done it myself a few times, testing them out. Nothing will happen except that the boards won't work right. So the only real caveat is when you're plugging them in, you have to be a little bit careful about making sure that you've actually got the pins lined up correctly. And I don't have a really good way to illustrate this, but you can see there's 2 rows of pins here. And if you aren't careful, you'll actually plug this row into the bottom row on the PCjr. So you kind of have to lift it up just a little bit when you're sliding it in to make sure. And as I mentioned, the other board actually sticks in there a little bit stronger. This one doesn't have as many teeth, and the board's a little bit heavier, so it tends to lean out a little bit. I would recommend putting some double-sided tape or something on the back of this board if you're going to stick it in there and leave it in there permanently, because I suspect most people like me aren't trying to use all the original peripherals or the original cables. They just really want this machine to be more functional, and that was really my kind of complaint with it, is getting a hold of the CGA cables. It looks like they were about $70. The serial cables were $50 to $70 as well. The keyboard connector cable was going from $20 to $30. And I never even found a joystick cable, so I don't even know if those are available, or how common they were to begin with. But whatever the case, you can plug this guy in and just use standard peripherals, which are a lot more prevalent. So I'm going to go ahead and show you a little bit of these ports in action and show you how they work. A shot of the boards side by side. I just wanted to let you get a look at them real quick next to each other. So here's the back of the machine. I just wanted to show it real quick and show how the cables are connect up. Here's the PS2 keyboard. And you can see the board moving around a little bit. Also forgive this one for being dirty. That's actually my board, and I never did clean it. So yours will be clean when you buy one. There's the RJ12 port for the PCjr Keyboard. And there's the joystick port. Actually, I'm using an IBM Easy Option joystick for the test. I'm also using an IBM keyboard from a mainframe console, but it's just a standard PS2 keyboard. There's the CGA port. And to test the serial port, I went ahead and I just plugged in as an old modem that I have, and using the software, the demo software, I'll show that it can connect to it. So there that guy is. Here's my CGA monitor, if you want to call it that. That's actually a GBS 8200 board, and up on top is the GG Labs RGBI to RGBS adapter. I'll put a link below for that because it's really handy, but this essentially turns a VGA monitor or flat screen into CGA, and that's what I'll be using for the test in this video. Here's just a quick look at the test setup. There's the PS2 keyboard I was talking about, and that's just a standard PS2 keyboard off of an old IBM. There's the PCjr Keyboard, and you can see my Gotek HXC floppy in there. There's a multi-tech modem that I have plugged into the serial port, and the IBM Easy Options joystick that I'll use for testing. Now I'm turning on the PCjr just to show it booting up real quick, and my camera adjust. But you can see that board works fairly well for CGA. And I do have a 640K RAM expansion plugged into it, so it takes it a moment to count up. I was going to show real quick that the PS2 keyboard's working okay. I've got it set for that. Do Control-Alt-Delete, show that the reboot's working and everything. Now that it's back up, I've got a utility that I found online called Joy Test, which somebody wrote many years back, and it's just a handy little program to make sure your joysticks are working. Here it is. You can see that the X and Y axes are moving around on joystick A, or joystick 1 as I call it. And the buttons are also responsive. And now I'm going to switch the joystick to the second port. And here's the same test on the second joystick. It's working pretty well as well. There are the buttons. And here's a test. I'm launching a program called AlleyCat. If you guys haven't seen it, it's a great old DOS game that I was never any good at. I was actually much better at with the keyboard than with the joystick. I never really had one back when I was a kid. Interesting to note, too, I'm not sure if this is taking advantage of the IBM PCjr color mode or what the deal is, but if you play this in CGA, it uses that ugly cyan pink palette, which I always hated, but it actually looks a lot better on the PCjr. So all you do is you get the program launched, go in, tell it you're using a joystick, and then you hit the button to start. As you can see, I'm completely terrible at this game, but I'm also trying to stand in front of the camera, so nope, got nailed already. Nope, here comes a dog. Great. Excellent work. And my last life. Will he make it more than 30 seconds? And nailed again. The end. So now I'm just going to show a quick test of the PCjr keyboard working, and please remember that my PCjr keyboard is not working very well, but I just need to move the jumper real quick. It's not too hard to move. I'm just using pliers to make it easy. And now it's in PCjr mode. And here we go. I've got it hooked up, sitting at a DOS prompt because the enter key doesn't work. You can see right off the bat I get some noise on my characters, but a lot of the keys are working just fine. And if you have a good keyboard, I have no doubt that it's going to work, but as you can see, mine's doing crazy things when you hit certain keys. So that's not indicative of the card, it's just my keyboard has a lot of nasty, messed up traces on it. Now I'm booting up the PCjr sampler disk, which comes with the PCjr originally. I've moved it over to USB because my floppy drive was having some fun problems, but this, if you haven't seen it before, is what the sampler program looks like. So I launched the modem test program, and forgive the background noise because I unmuted the camera video on this part just so you can hear the sound of the modem as it's actually working. So the first thing I'm doing is just entering a few ATI commands which just show the information about the modem. Just, if you look at the lights on the modem, you can see that they're flashing there as it's sending and receiving data. And that's just connected to the serial port on the PCjr. And now I'm going to dial a number that I don't have a phone line hooked up. I'm just dialing a bunch of random numbers. Success. Well, that's about the end of the demo. I just wanted to show that everything's working on there, and it should make your PCjr a lot more handy to use. If you're interested in buying these, certainly feel free to take a look at our store, TexElec.com. And we also sell them on eBay if you prefer to purchase through there in our store, which is also called TexElec. I just wanted to leave you with one more thing that's something else we're working on, and that's this ISA bus that will stick out of the side of the machine. Now this is a prototype that I've been working on, and it does work for the most part. The voltage regulator that I have on there, I'm not really happy with those guys. It's not something that I built, it's something that I bought from China, and unfortunately I bought 5 of them and 2 of them worked reliably. So it's probably not the route I'm going to take. I'm looking at other power supply options because the original PCjr kind of has a few drawbacks. One of them is it doesn't supply negative 12 volts, which specifically the resound card that we sell, I was able to get to work once I used bench power supplies and hooked it up. I also got the low-tech 640K memory expansion board to work on there, which was nice. But as I've done some more reading, I realized that there's certain limitations. Like, as I understand, I don't actually have a cartridge, unfortunately, for my PCjr at this point, but if you have a cartridge plugged into the first port, there's some issues with the address lines and a few other random things. But just to let you know that it's something that we're working on, and unfortunately, I do think that there's going to be a lot of caveats. Also, if you see up there where it's got that X1 next to the power supply, that's actually a crystal to supply the right bus speed to the bus, as the PCjr didn't supply that either. It was very limited on what interrupts it would provide, and it provided interrupt 1 of all strange things. And I actually spoke with Mike Brutman through email, and he recommended, you know, putting a jumper on so you could, say, map IRQ7 or whatever to IRQ1. And that way, with software, you could, you know, make use of at least the 1 additional interrupt. Because otherwise, I think all you have is, if I remember correctly, is 2 and 5. But don't quote me on that. That's just what I remember from doing some reading before. But anyway, just wanted to give a little teaser that I am actually working on an ISA expansion board, and this prototype does work. And right now, there's another board that I saw actually on the PCjr page that kind of gave me the idea to do this. I don't see any of them for sale out there. The cards are actually facing, I guess, what you would call backwards on here. And I guess the idea behind that is if you had, say, a long or full-length ISA card, it's just going to be kind of floating in the wind and sticking out further back. I went ahead and I followed that same direction, which made the leads kind of challenging to hook up. But I could actually design it to where the cards are facing in the back like they would on a regular PC, and then sticking out in the front of the machine. So any comments or thoughts on what you'd like to see in a card like this, let me know. At this point, I don't have these ready for sale. It's just something that I've been kind of playing around with when I have some spare time, and I'm also working on several other things, so this one's kind of on the back burner at the moment. But as it sits, it does work. It just didn't really, unfortunately, the voltage regulator didn't really work out the way I'd hoped. Well, I think that's a long enough video for this time around. Thanks for watching, everyone, and feel free to leave comments, and please subscribe to our channel. We certainly would like to see more subscribers out there and get our word out a little bit more. I'm continuing to develop stuff and working with my wife here in-house to get some great products out to you guys. Thanks so much for watching, and have a great day.